Hello, everybody, and welcome to our webinar. We're excited to have you today. We're going to be talking about how to modernize your maintenance. And during this webinar, we're going to give a roadmap to creating a predictive maintenance strategy. So we have a great session planned, and we look forward to sharing our insights that you can put into action right away. My name is Amissa, and I'm the Director of Engagement here at Uptime Solutions. I'm also a certified maintenance and reliability professional, and that gives me a unique perspective on how maintenance and reliability teams operate. And I'm going to be your host and walking you through our session today. So before we dive in though, let's quickly cover how you can interact during the webinar. So if you have a question at any point, you can type it into the Q&A panel, and we're going to address as many questions as we can during the webinar, mostly at the end. And then if you have any general comments or reactions to what we're talking about, feel free to type those into the chat. We like to see anyone's thoughts and anything you want to share throughout the webinar so we can stay interactive during the presentation. All right. Well, I am excited to introduce you to our featured expert speakers today, Matt and Brian. Brian, do you want to kick us off by introducing yourself and telling us a little bit about you and your background?
Sure. Thanks, Amissa. Thanks, everybody, for coming. We hope that we can drop some nuggets here that will allow you to have some action in your maintenance and reliability program to start moving through all the levels of how your maintenance and reliability systems and programs function. But anyway, I'm Brian. I'm the Vice President of Maintenance Programs here at Uptime. I've spent a lot of time turning wrenches, building maintenance programs, leading teams, and doing the work. Matt is way cooler than me, so I'll let him go next.
I'm glad we established that right away. But LinkedIn Nation, good to see you guys again. Looks like we got a packed house today, right, Amissa? So things are looking good there. The three of us are glad to have you all here again. If you don't know me, my name is Matt. I'm the VP of Reliability Solutions here at Uptime. Very quickly, for the past 25 years, I've been heavily involved in condition monitoring, reliability, and industrial equipment repair, working and collaborating with hundreds of major manufacturing and facilities globally to help them solve their toughest challenges. And as my colleagues said, we're very excited to be here today and with you all, and really hope you gain some good insight into the world of condition monitoring and asset reliability. How you feeling, Brian? How you doing, brother? Good?
Feel great. Yep. Just ready to rip.
All right, man. You guys take it away.
All right. So this is the agenda and what we're going to cover today. So first, we're going to talk about why preventative maintenance should be optimized. We're going to talk about how to understand some key concepts about predictive maintenance. We're going to talk about identifying critical assets and how to prioritize your equipment when you're doing predictive maintenance. Matt's going to dive into choosing the right monitoring tools. We're going to talk about how to implement a predictive maintenance program. We're going to talk about data-driven decision making, and then we will touch on some real-world examples of companies that have applied this. And then we'll do a quick wrap up and some Q&A at the end. Go ahead, Matt and Brian.
All right. Thank you, Amissa. So we have a laundry list of things to get through today. So we'll try to keep this pointed as best as we possibly can. So we talk about preventive maintenance here, right? What the reality of it. When anybody talks about maintenance, they think of preventive maintenance. I got to do this thing to replace this thing before it breaks and whatnot, right? So time-based preventive maintenance is I change X or I do X at this time every 2 months, 3 months, 1 week, 4 days, 10 hours, 15 hours, right? So a lot of times, if failure mechanisms are not associated with your preventive maintenance program, a lot of times you're going to over maintain items or you're going to under maintain items. And in those evolutions, you're going to miss failures because we don't know what failure mechanisms we should be looking for, right? So unplanned downtime, right? So preventive maintenance is there to maintain the function of an asset. And if we do not maintain that function, then we get a functional failure. We get a breakdown through a failure mode or mechanism or whatever. So planned maintenance is to address functions to try to reduce unplanned downtime, but it's not always going to do that. And then non-value added PM workloads. Okay, so everybody knows this. Everybody on this webinar probably can go into their CMMS, pull up a PM and read a task, and it probably says check belt, check chain, grease this, look at this shaft. Like those are all things that are great, but they're not pointed, they're not directed, and therefore we can be maintaining things and doing unnecessary work for no reason. And ultimately, the big thing with non-value added PM, one, you're not addressing failure modes, but the biggest one is you're increasing variability. You're having people touch things, take things apart, and fiddle with things that don't need it, right? And we all know that human-induced failures are rampant in maintenance and reliability. And then, of course, preventive maintenance, as we talk about unplanned downtime, you're still typically, you're doing a lot of emergency work and it's dominating the schedule. We talked to some people yesterday, I think, and they had mentioned that, upwards of 40, 50% of their schedule is just corrective reactive work. So there's a lot there. These are the things that we want to optimize. We want to get ahead. We want to start talking about these topics, and we want to start figuring out how do we enable these topics or these items in preventive maintenance for long-term value. And we'll get into a lot of that. You got anything to add, Matt?
Yeah, brother. I'm just going to jump on what you just said there at the end. Great analysis on all four of those points. I'm just going to touch on briefly on the last point to what you're saying about like our conversation with some folks yesterday, right? It's pretty wild to think just how common the frustration of emergency work still dominating schedules is, right? I mean, it's here we are, been in industry this long, right? All the tools at our disposal, and that's still a big thing. So from a condition monitoring side, you invest heavily in standing up a CM program and training and yet you still have emergency calls, like you said, dominating. The reason condition monitoring often fails to eliminate emergency work is rarely the technology itself, right? I mean, granted that the technology is the right technology for the application that you're monitoring, and it's capable, right? But to me, what the failures I see is it's in the ecosystem itself around that data, right? You were touching a little bit on that, the culture. So unfortunately, many times the default mentality is, I'm sure you would agree with me on this, is because the machine is still running, the work is deferred in favor of today's productions, right? And we all know what that leads to tomorrow, right? So I'll just add this little nugget, as you like to say, detection is not correction. If you're monitoring defects, if your monitoring detects a fault on a Monday, but your parts procurement takes 2 weeks to get, and the machine fails on Wednesday, the monitoring wasn't successful, right, Brian? But the maintenance was a failure. I mean, the monitoring was successful, but the maintenance was a failure.
Yeah, so that brings me into that's one, and we'll touch more on this in here. I just want to not forget. If you're planning on employing condition monitoring in your space, you better be so good at planning and scheduling, because corrective or condition monitoring is going to generate corrective work. It's going to modify your preventive work. And if you don't have the tools in place to handle those workloads and that data coming in, you might as well not even do it. Because as Matt knows, we all know, as he said, just because you're monitoring things doesn't mean you're getting more reliable. The action outside of the monitoring is what drives reliability.
That's right.
Okay. So maturity gaps. Hold on, my face is in the way of this. Let me move it over here. Okay. So typically we're moving reactive, preventive, condition, predictive, right? There's levels of maturity that we kind of move through naturally as we start to understand our assets, as we start to make impact within our business and drive cultural change and all those types of things. So reactive is we're fixing equipment after it fails, right? We may have some indicators, maybe we don't know what to do. We don't have the means to do the right things. Equipment fails, we restore it. Now, run to failure is a totally acceptable strategy for some assets. You just have to make sure you go down the road to understand why you're letting a machine fail, right? Preventive is where everybody falls. So you can have preventive corrective work, right? So that's work that's found proactively on a preventive maintenance task that then you schedule. It's still corrective, but it's in a preventive strategy, right? So you're performing scheduled maintenance to preserve equipment function. We talked a little bit of that on the last slide. You want to preserve the function, the design, context, and function of an asset. And then predictive or condition-based, right, is we're using data, sensors, technology to understand equipment before it fails and mitigate the risk. That's a very important point. And I think Matt would agree, like we talked about in the last, like just because you're monitoring things doesn't mean now you're predictive. Now you're going to eliminate downtime, right? We're mitigating the effects of downtime and the mitigating the risk, right? The compounding effects. We're stopping things. We're doing the right work at the right time with the right resources, all that, right? So a lot of people get stuck in preventive because it's a good place to be stuck in. I will be honest, right? I'd rather be stuck in preventive than reactive. But if you really want to optimize, you have to move towards understanding failure mechanisms and failure modes, and then using that data to then drive the long-term outcomes and preventive maintenance tasks and corrective maintenance tasks and work schedules and tooling and technology, all those things you're going to need to get way ahead, right? So, okay. All right. Let me move my face again. Understanding predictive maintenance concepts and key benefits. All right. So, what predictive maintenance actually is, what it is, right? Condition based maintenance is driven by asset health data, right? We're monitoring condition and we are basing our work on actual condition and context of an asset. We're using, there you go. We're using operating conditions, not time based schedules. We are analyzing failures early so action can be planned and not be reactive, right? We want to be able to know with some, confidence, strong confidence that we have this much time before this work needs to be carried out before we experience a functional failure. And remember, when we're using technology to pick up defects, whether it's ultrasound, vibration, temperature, the failure has already started. You're not mitigating the failure start, right? You're mitigating the risk and trying to build the longest timeline to then intervene at the right time, planned and not unplanned, right? And then we want to enable the right work at the right time, as I just alluded to. I'm getting ahead of myself here. What it's not, and we hear this all the time, we don't want alarms. If you're installing sensors that just beep at you all day long and ping and tell you whatever, right? That's not very effective. You're going to get analysis paralysis. You're going to get alarm overload, and it's just not. No one's going to pay attention to it anymore, right? Especially if it doesn't yield any actual results. And it doesn't replace your PMs, right? And dashboards don't do anything unless you act on them. And I'll stop there. Go ahead, Matt.
Yeah, thanks, Brian. I'll just briefly comment on one point here that really sticks out, and the one that drives me absolutely crazy, as you know, is the install and wait for alarms point, right? So the install and wait approach to condition monitoring is a classic trap, wouldn't you agree?
Oh, yeah. Yes.
While it feels proactive, and I'm going to ask you, I know you got a saying for this, but I'll say this, while it feels proactive because you have sensors, it still results in a reactive culture, right? It just has that digital facade. Now, what's your phrase on the momentum
Oh,
and all movement?
yeah, yeah. My favorite phrase with all this type of stuff when people are talking about anything that seems to be a silver bullet without actually action is there's a difference between the feeling of motion and actual movement. So a lot of these things make you feel good. Oh, I got a sensor on the pump. Now we're good to go. Nah, not really. Right. So don't get caught in the trap of thinking that the motion you feel is actual movement.
Yeah, thank you for that. I love that phrase. And just to wrap up on here, I'll also say if your only trigger for action is an alarm, you're essentially waiting for the machine to tell you it's already failed, right? Or that it's very close to failing. An alarm tells you that a threshold was crossed, which is great. But what it does not tell you is the why. So without trending the data leading up to that point, I would say you really can't distinguish between a sudden catastrophic break and a slow manageable wear, right? Wear and tear issue. So, as we discussed coming into this in this webinar, I said, man, I could talk for 3 days on, how to successfully set alarms. Some of the old school ways that we've done it over the years and different things, but really in a nutshell, to set alarms successfully, um, you not only need a highly skilled analyst, and let me say that again, you not only need a highly skilled analyst, but you also need that analyst to be very familiar with the processes, right? The process variables that affect the machine vibration. And I'm gonna deep dive into that a little bit more here as we move along.
Right on. Okay, go ahead, Matt.
Oh man, it's me again. Thought I was gonna get a break. So what do we got here? Core predictive maintenance concepts, condition monitoring, failure modes and early warning signs, actionable insights versus raw data. All very good points, but let's first define condition monitoring, right? So simply, very simply, condition monitoring is the process of tracking specific parameters of machinery, such as whether it's vibration, temperature, pressure, flow, current, whatever, right? So to identify changes that indicate a developing fault, excuse me. So at the heart of condition monitoring, I would say is about coming alongside let me rephrase that. At its heart, condition monitoring is about coming alongside, or in the right instance, moving away from calendar-based PM maintenance, which Brian was touching on earlier, more towards a maintenance-based, moving away from calendar-based maintenance toward evidence-based, right? Based on what we're seeing in those in that spectra. So to revisit the previous slide that we were talking about, moving beyond installing and waiting for alarms, again, a professional condition monitoring, a professional CM program is going to follow 4 steps that I have here in front of me. One is data acquisition, right? Using sensors, thermal imagery, motor current, ultrasound, motion amplification, et cetera, right? To capture those raw physical signals. Number 2, data processing, converting those raw signals into understandable metrics, converting a complex vibration time waveform into a simple FFT, right? For the analyst to understand, if you will. Condition analysis, and diagnosis, right? So determining what's wrong. Is the high vibration caused by a bad bearing, or is the machine simply unbalanced, right? Or was there a high vibration spike, again, based on what we see another upcoming seminar that I'm giving? I'm talking about how machines are pushed way beyond their capacity, right? Their design intentions. And we see that a lot of times where all of a sudden something's running 30% out of its design, and now it's running in a critical speed, right? So we got to look at those things. And then, of course, lastly, the prognosis of it, right? So predicting when the failure will occur. And really, this is the transition from condition monitoring into the predictive side of the analytics. So moving from identifying the onset of a functional failure to predicting when that failure will likely become a complete failure. That's really at the heart of what a skilled analyst is looking to achieve, right? And that skill comes from many years of experience and having the right high quality data at your fingertips, plain and simple.
Right on. I just have one thing to add.
Mm-hmm.
And that is just for everyone's that's listening. And I think we'll talk about this a little further, but failure modes and failure mechanisms are not the same. The failure mode is the what you see from the failure, right? The shaft broke. That's a mode. The mechanism would be the shaft broke because it had a crack from corrosion or overload or something, right? So the mechanism drives the mode. The mode is what you see. The mechanism is like kind of the underlying root of why that failure mode was able to propagate. Just want to keep that in everyone's head as we go through this. Okay. Business benefits of a condition monitoring program, right? Well, we want to reduce unplanned downtime. Downtime is downtime regardless of if it's planned or unplanned. But if we can all mobilize and we can be on the same time scale, we can put things in place, we can create a down day, we can let our customers know, we can let operations know, we can do all these things. It's better to do it planned than unplanned. Not to mention, when you do things planned, you have what I call opportunistic maintenance. You have the ability to also address and look at other things while you have that downtime, right? We want to extend asset life. So the best way to extend asset life is to take the failure modes and mechanisms that you understand through condition monitoring and systematically design them out in iteration or in repair. If I have a vertical pump, a vertical motor that drives a pump down in a well, right? And I come to find out that we're getting the thrust bearings on the snout or the case or shaft, output shaft of that motor keep failing every year. We come to find out that motor wasn't even designed to be in the vertical position. So it doesn't have the correct thrust bearings on the front of that shaft to take on that wear and stuff like that. So like you want to extend asset life through design changes, lubricant change, like anything that's going to eliminate a mechanism that's causing you failure. Better labor planning. I mean, this should just say better resource planning in general, right? When we plan work and we give a good timeline to failure and we want to mitigate and intervene at the right time, you're saving resources. You don't overnight parts. You don't have to call people in at the off hours. You don't have to tool up different types of tools. You don't have to get contractors lined up. You don't have to worry about the compounding effects of standby labor. And like it just goes on and on and on, right? And then we're going to improve our reliability metrics, right? We're going to start to see that our wrench time is getting better. We're going to start to see that 90% of our schedule now are just operational checks, right? Or active inspections where we're just verifying context and operation and not intervening in machines because we don't have to, right? So there's a lot there. There's a lot to the business. And most of the impact is going to come from resource management and extending life, right? You have anything to add, Matt?
Yeah, just briefly, like you said, better resource planning. That to me, that really sticks out, right? I'll just add, to me, the most important outcome of predictive maintenance is planning. That's the whole. That's, I would say, early detection of failure modes is the holy grail of maintenance, right? I mean,
Yep.
because it converts a random chaotic event into a controlled, manageable task, like what you're saying. And let's be honest, anytime anything's rushed, it never ends well, at least not for me or my children. But so again, the goal is to provide months of lead time, allowing your planners, like Brian said, to order long lead parts, get maintenance personnel, contractors, all that, get the procedures. But I'll just end with this. If you are only catching failure modes a few weeks out, you're still operating in a reactive state.
And that's a fact because the planner should be planning work 2, 3, 4 weeks in advance. So keep planning and scheduling in your mind this entire time. It's funny how everything comes back to the most simplest things in maintenance that nobody does. All right. Identifying critical assets, how to prioritize your equipment. Go ahead, Matt.
All right. What do we got? Time's moving along, so I'll try to get through this quickly. Both great points, but let's be honest, monitoring everything would be great, but based on the situation or culture of the plant, it's not always feasible, right? Again, we could talk for days on that. So, which could be due to factors such as cost, right? Manpower, what subject matter knowledge is available in the mill. Nowadays, with the vast amounts of data we can generate, we have in some cases, and this is my opinion, due to these large amounts of data, that we've thrown out common sense and years of asset reliability training and tribal knowledge, right? I think we want to become so dependent, or we're becoming so dependent on that stuff. And I think people have fallen into this false sense of safety and reliability due to that, having access to those vast amounts of data sometimes. Um, I've seen many new programs, right? What are we talking about? Common mistakes. So many new programs try to boil the ocean in a day. And by installing a million sensors at once without properly implementing, having a champion of the program, as you hear me talk a lot about, really causing the whole entire project to be scrapped before it yields anything, right? I mean, a lot of times I seen it in my career. We bought all these data collectors. Here's the software. Go figure it out, right? It never ends well. So in reality, simply turns an unprioritized, excuse me, condition monitoring program into a data graveyard. Really, really. Alarm fatigue, like you touched on, analysis paralysis, you said, economic waste. And I think you and I were talking the other day about that false sense of busyness. So that all leads to diminishing return, right? And it's really, and dilution of resources. So I would say, and Brian would probably agree with this, just a few final thoughts is implement a criticality matrix of some sort. And remember, more data doesn't always equal more reliable. Try to keep quality of data over quantity is paramount.
100%. And that's why when people tell me that the only metric that they track in their CMMS is PM completion, I go, that's great, but you could be really, really good at doing the wrong work.
Right.
All right. Asset criticality basics, right? These are factors we want to consider when we want to understand our criticality. Now, I will say this before I get into all this stuff. Well, actually, we added it. Never mind. So, safety. If you have assets that are a risk to the environment, to compliance, to human life, to other assets, the building, infrastructure, whatever, you got to take that into consideration, right? We have production impact, not just my machine stopped and now I'm not producing X, but also my machine stopped, now I'm not producing X, and therefore machine downstream A, B, C, and D can now not do whatever. And oh, by the way, we have 55 people who are standing by getting paid while this machine is still down. There's a lot associated with that. Talk about repair cost. Are machines very, very expensive to repair once they have failed? To restore their function, what does it take? Do you have to get contractors? Do you have to have special tooling? Do you have to have all this? Do you have to get cranes rigged? Do you have to pull the ceiling off the building? It happens. Trust me. So you got to think about all that stuff when it comes into your criticality. This one's my favorite since we're talking about condition monitoring. Failure frequency, right? We want to know or try to at least understand that SDO means something. It's severity, detection, and occurrence. How bad is it going to be if it fails? How easy or hard is it to detect? And how often does it happen? These are things we should be asking ourselves. And a good note here for the pros out there, use your risk priority numbers, your RPNs, right? It's a literally a matrix that you can just kind of gauge based on historical data, engineering information, or whatever, right? So you can understand impact and criticality. And then, yeah, take a simple criticality ranking approach. Use the ones above us. Just because someone says if this machine stops, then the whole world stops, ask a couple more questions. Let's just make sure, because there could be more to that, not less. Okay, where PDM delivers the fastest return on your investment, right? Rotating equipment. Matt taught me this. If it rotates, it vibrates, right? Or it shakes, it moves, it's got mechanical looseness, everything, right? So we talk about rotating equipment. Assets with known failure patterns. That's huge. If you understand failure patterns, then leverage that data and make a good condition monitoring process out of it. Bottleneck equipment, right? I hear about redundancy a lot from talking to a lot of people. Redundancy is not reliability, okay? But bottlenecking is a huge problem. A lot of times, all it takes is walking out in the shop floor and see what the heck's going on, right? So if you have bottlenecking equipment, which we talk about, that can affect downstream processes, you might want to think about monitoring it. And then, of course, my favorite, I say it all the time, compounding effects. What are we not seeing here that is impacting this machine being down, broken, repaired, having to be pulled out of service? What else is there? There could be a lot. We need to ask those questions. You have anything to add, Matt?
Yeah, I just want people to keep in mind, really this is that is a great overview, but it can a lot of times be a really an industry by industry discussion as well, right? So if you take like the steel industry, just kind of bringing this where the PEDM delivers is if you look at the steel industry who uses, who might be using a pickling process, which uses highly corrosive chemicals, right? Hydrochloric acid, sulfuric acid, which can greatly reduce the life cycle of those bearings in there, right?
Mm-hmm.
Uh, or due to the high temperature. Same things when all the foundries I've done across the U.S. Extremely abrasive with the mold sand, extreme temperatures, right? Life cycles of bearings and assets going way down. And then of course all the like we were talking about the process, right? Process variables and different things, and like pulp and paper, plastics and things like that. We can go
Yeah,
ahead.
100%. You gotta know what you're looking at if you want to chart driving value from these things. Choosing the right monitoring tools. Go ahead, Maddie.
All right. When each makes sense. Well, they all make sense, right? But as the old saying goes, the right tool for the job. Many claim, and the thing that drives me nuts over the last 15 years is this one size fits all solution, really. And that's probably what really triggered my public speaking, is because that thought, when I saw that marketing, it just really outraged me. Those of you know, I've calmed down quite a bit over the last year, maybe not. But anyways, um, that one size fits all solution, but unfortunately, that does not exist. I don't care what people are telling you, it doesn't. So let's just touch here very quick on the big four. I call it the big four. Many of us in the space who've been doing this a long time call it the big four, meaning used in 80% of programs, right? So vibration analysis has been the gold standard for many years for mechanical health, right? Thermography, love it. Detects heat signatures and friction. We all know that. Oil analysis, been around for over 80 years. That's probably the OG of condition monitoring right there. And it's still at the top of my list as far as, it's like the blood test for the machines, right? Um, and then ultrasound. Ultrasound is great. To me, ultrasound was kind of the redheaded stepchild for many years when it came out. Some people kind of pushed back on it because what they'd known for years was was vibration, but I absolutely love it. Not just because we do it, but I used it in a lot of cases where it's done just amazing things for listening for them high frequencies, right? And also, I want to mention ESA and MCSA, which is really super, super cool. And a good friend of ours, is out there blazing the trails, and showing the what a phenomenal tool that is as well.
Yeah, that's just for you guys to know. That's electrical signature analysis and motor signature
Yeah,
analysis.
thank you.
Okay.
You're my translator today.
I'm just a guy here that likes talking about maintenance. That's all, man.
Missa, what do we got? How are we looking on time?
All right. Go ahead,
Thumbs
Matt.
up. That's all I got. Couldn't even get nothing. Oh man. All right. Fixed versus wireless. Thanks for that, Amissa. Again, this is um, oh boy. Where can we go with this? I lost my page here. Here we go. Okay, so let's look at it like this. So choosing between a fixed or a wireless condition monitoring solution depends heavily on the criticality, which we already talked about, right, Brian, of the asset, the physical environment, like I was just referring to in the last slide. Um, while wireless technology certainly has advanced, we obviously love it. Wired systems, again, using the term gold standard, remain wired systems remain the gold standard for highly critical assets a lot of time, just because and I'll break that down a little bit. I'm not taking anything away from either one, but what I try to teach people is, again, the right tool for the job, right? What's the application? Bring that bring the right tool to that application. Don't just, like I said, the one size fits all and hope it covers everything, right? Um, that's hence why, like in the wired side, when I say that, still see many of the legacy condition monitoring companies still going strong, especially in the turbo machinery industry, right? Um, so I'm just going to go through a couple bullet points here. So wired systems provides continuous real-time data streaming, right? Because they have a constant power source. Wired sensors can capture high frequency waveforms for like what I'm saying for high speed turbines or complex gearboxes without any gaps in the data, which is essential for detailed root cause analysis. Very labor intensive in some cases and expensive to install because of having to run based on what the plant wants, right? Conduit wiring, things like that, making long runs. Uh, and of course, you got to bring in more labor, right, to run all that stuff, and that becomes a very big expense, as you know, Brian, from running programs as a maintenance manager. Um, they're virtually maintenance free once installed, a lot of times, right, versus the wireless where there's no batteries. And some of those to change, and the hardware is often built to last decades in harsh, high temperature environments. And highly stable. So, the physical cables are immune to radio frequency interference, common in some industrial plants, right? From welders, motors, thick concrete or steel walls. Wireless typically operates on scheduled intervals. So once every hour, once every whatever you feel deemed based on that criticality, right? And that's because we need to preserve that battery life, right? While excellent for trend analysis, they may miss some transient events that occur between samples. But again, based on criticality, what you do is how you set up how often you want to check that, right? Very great for plug and play deployment. Sensors can be mounted up very quickly. Uh, makes it very ideal for scaling across a plant versus having to go hardwired in on everything. Um, Again, requires some of the cons maybe is requiring battery management strategy, but that's nothing new. That's something we've been doing in this space for quite a while. And again, that depends on sampling rates, um, and how much you got deployed across there, right? So I hope that touches it. I know we're getting short on time, so I want to kind of get through it pretty quick, but I would say, you got anything to add to that, Brian, as far as what you've seen in your experience?
No, it's spot on. Like I said, I've had when I was running, coal facilities, I had calendar based uh, company that would come in and do our analysis. Every month or so, or 3 months, they'd come in and do a whole route based effect because it was more cost effective, right, at the time.
Sure.
And it provided that perfect picture of data that you described. So yeah, 100%. Go ahead, Matt.
All right, let's blast through this dashboards. You had alluded to that a little bit. I like to say dashboards tell you the history, alerts tell you the emergency, but experts tell you the future. That's the bottom line with that, right? So dashboards, visual, high level, summaries, they can provide a big picture based on, many of them are customizable, so you get to see what you want, right? Um, at any given moment. So what I've seen in my experience, the pros of those are trend analysis, right? Easy to see if the bearing temperature is slowly creeping up, vibrations creeping up, whatever your parameters are that you want to look at. System context, right? Shows how different machines interact with what's going on, maybe with some process variables and different things. And one of the pros that I like of that is accountability, right? Provides a single source of truth for management if they want to look at that. Again, all depends on if it's set up correctly. Some of the cons, they can be passive, right? They require someone to look at them. If no one checks the screen, the problem can go unnoticed. If they're solely resting on that, and sometimes a lot like we talk about analysis paralysis or alert fatigue, you can get dashboard fatigue as well, where people are just looking for that green light, right? Um, Alerts, again, getting into that, we could speak for days on that, but alerts are a reactive notification. Um, Basically trigger when it's specific, like we talked before. So I don't want to spend a lot of time on this, but the pros are it gives an immediate response, right? Notifies the right person, hopefully instantly via text, email, whatever. Again, if it's set up correctly to send that information to somebody like Brian. Brian, go out there and get the right person out there to look at it and try to find out the why, right? The what, the why. Technicians don't have to waste time watching monitors, I guess. Cons, again, we already talked about it, alert fatigue. And to me, if you're just basing your analysis off alerts, you really lack a lot of context. So an alert tells you that a limit was reached, but rarely explains the why, as we talked before. So again, I would say in the interest of time here, the human element, right? Turning data into action is key. Data alone doesn't fix the machines. Expert analyst and that collaboration, as we talked about in our previous webinar on, not operating in silos, bringing everybody to the table and working on it. But we'll keep moving.
Right on. Okay. Integrations. CMMS, your enterprise asset management integrations, right? So we don't, ideally, specifically because of resource constraints and maybe educational constraints, we don't want to be looking at 10 different screens to figure out what's going on, right? I got my CMMS, I got my condition monitoring software, I've got my SCADA system, I've got my ignition, I've got like process data, like all these different things. If we integrate, we can create dashboards, or we can create those symbiotic relationships with the software, so that the people that need to be in the loop, need to see these things, they're looking at one thing or maybe two things, right? So we want to keep that commonality, we want to keep that transparency, we want to make things simple so that we can integrate data, and then the people who are good at using their CMMS can continue using their CMMS with the right information. The people who are good at analyzing data on the fancy software, they're good at that, they do that, and then those two systems communicate with the appropriate amount of knowledge and information. Workflow considerations, same type of thing. Do you want a alert to generate a work order, or do you want an analyst's prescriptive understanding of data to generate a corrective work order? So you got to think about those things. And then again, I touched on it, a disconnected system, right? I've talked to many people like, oh, we have this system. Like, cool, what do you do with it? Oh, no one's ever looked at it. It's just there, right? So we want to create that transparency and that commonality in the data to where it's visualized and maximized for who needs to see it and who needs to interact with it. Anything to add, Matt?
Nope, we're good.
Implementing a predictive maintenance program. Go ahead, Matt.
Yeah, I know we're getting short on time, Amissa, but I do want to spend a little bit of time on this because I think people really need to understand pilots and how to stay out of pilot purgatory, as Jeremy says, and other things, right? Because we see pilots more now than we ever have in the past. So I'm just going to briefly talk about why pilots work, and for that matter, why they might not. So pilots are effective when they bridge the gap between the technology and the methods. It's a way of de-risking investment, if you will, right? So it allows the people who are cutting the checks for these things to see to hopefully be able to prove the value in that short time. That is kind of the conundrum of pilots is, if you're old school like us, right, Brian, if you're looking at PF curves and different things, people might be putting sensors on something that might run for 20 years and then look at it like, hey, this pilot's not successful. We didn't find anything. So if you're going into a pilot and basing your success solely on if you find something during that pilot, I would say you need to rethink your criteria of what success looks like. And they're good for buying or building internal buy-in, right? So hopefully, again, you get to see it successfully deliver on what was advertised, right? And you can get some wins. Moving down the scope, asset selection. I'm not going to pile on that. Brian already talked about the asset criticality, right? So usually in a pilot, you're looking at about maybe 10 or 15 assets, and you want to kind of spread that out on different criticality, whether it's air compressors, maybe some dryer bearings, whatever you want to look at, right? To get a good feel holistically across the board. And I think the biggest thing is what Emissa has on this slide here is success criteria. And that can kind of be defined plant by plant, but I do have 4 points here on what I think should meet specific benchmarks is one, Brian, anybody who knows me, I'm big on early detection. To me, early detection is everything. Again, if your technology is only catching something 4 to 6 weeks out, to me, that's reactive. We want to see that as far out as we can so we can maximize that maintenance planning window, right? So early detection, data accuracy, meaning a low rate of false positives, and actionability. Did the alerts provide enough lead time? Again, going back to that early detection. And then ROI evidence. It's hard to get away from that word, but that again is that's the difficulty of trying to build that ROI evidence in that short period of time for that pilot. But there are things where value can be seen, but hard to put a price tag on in some cases, right?
Only two things to add. Cost and value are not the same thing.
Mm-hmm.
And also, talking about the success criteria, ask yourself, what does good look like? And if you're trying to justify ROI, everyone is talking about dollars and cents, right? And there's going to be a lot of intangibles that are actually good in favor, but you can't attribute money to it. Try your damnedest. Think about labor costs. Think about tooling. Think about all contractors. Think about overtime. Think about overnighting a part. Right? There's a lot of ways to look at justification and return on condition monitoring. It doesn't just have to be it found a bearing, it saved us $500,000. It could be it found a defect that we understand now. And since we understand it, we've changed our preventive maintenance process and we save 50 hours of manpower a week. That's a big number, right? So think about it in terms of in terms that makes sense for the maintenance and reliability world. Go ahead, Matt.
Yeah, I'm going to blast through this real quick again in interest of time. If anybody wants to discuss offline with me, best practices on building condition monitoring programs, I would be happy to discuss that with you. But I would say justification is number one, right? Determine program level, assemble a plant team, a predictive maintenance team. You need the hardware and the software. You need to select the optimum machines, right? Going back to what Brian was saying, getting with your reliability team and getting everybody at the table to take a look at that criticality. And then again, what technologies do we need to purchase or employ, right, on our assets? Establish alarm criteria. If you're using alarms, alarms aren't always used on every piece of equipment. That's another discussion for another time. But and then again, setting up the computer database, right? This is all the stuff where all the hard work goes in on the front side of it. And then basically from there, you're just collecting your measurements, right? You're storing your data, you're compiling reports. You're looking at how often we should be monitoring, whether that's route-based, online, or hardwire or wireless. And then again, kind of just rinse and repeat, right? And then you have to take an honest look at it and see where it's working. And if it's not working, lick your wounds and keep making that actual forward momentum and say, okay, where can we make adjustments to make this successful?
Only thing I have to add is all great, Matt. Only thing I have to add is if your team is doing repetitive preventive maintenance tasks that are not generating a corrective work order or any kind of inspection process, you need to understand more about your assets, and condition monitoring is a tool to understand more about your assets to fine tune those tasks. Okay. Good, Matt.
Well, I would say that reliability and condition monitoring departments share a core commonality, right? Optimizing the performance and lifespan of their plant's assets, right? Like you said, defect elimination. That's a word you don't really hear a lot. Um, Connected to most condition monitoring programs. It's like, hey, we're out there, we're just looking for bad bearings. But the defect elimination and actually taking that data and getting deeper, right? So for me, again, I'm going to blast through this, but in my mind, the things that I live by is five elements, right? Leadership, communication, teamwork, documented standards, and fostering a reliability mentality and collaboration.
Only thing I have to add is create yourself a RACI chart: responsibility, accountability, consult, and inform.
Mhm.
Everybody should know what their role is in all these different processes, whether it's who gets an alert, whether it's who does the PM off the alert, who whatever, right? Create those RACI charts so people know, train on them so everybody knows, and then modify them as you move along. But it creates very clear lines of who should be doing what, both maintenance, reliability, and operations. Oh, and by the way, all three of those departments should be best friends. Whatever you got to do, squash it, make it happen. Be a strong leader. Okay. Measuring success, KPIs to track. I don't like talking about KPIs a lot because they're just so like they can be arbitrary in one place and awesome in the next place or whatever, right? So we talk about downtime reduction. If you're tracking labor hours and production time, you can understand downtime. Cost is a little more tricky because of all the compounding effects that we talked about. This is more important, in my opinion, because less downtime will happen if we optimize our preventive maintenance strategy, which comes from the data we get from condition monitoring. Do the right work at the right time with the right resources, addressing the correct failure mechanism or mode, and you will reduce downtime. And then notice how this is worded here: maintenance cost avoidance. I'm sure Amissa has heard me till I was blue in the face saying these things, but you're not saving money, you're avoiding cost, you're avoiding risk, which have a financial impact. But we don't like to say you're saving money because then I've been challenged in that in the past where they go, where's the money I'm saving? It's just going to go to something else, right? So we want to avoid cost, we want to avoid risk. Anything to add there, Matt?
No, I'm good.
Right on. Okay, data driven decision making. Go ahead,
All
Matt.
right. So what we're doing here on this slide is we're moving from raw data to real world maintenance actions, right? Which is, as Brian knows, it's a journey of refinement. So the goal isn't, as I like to say, the goal isn't to collect the most data, but to generate the most clarity from that data on, what your actions are going to be, right? So just moving through here, data, right? The foundation, information is the what, insights are the why and the when, and the action is the result. To me, it's that simple. Um, the most common failure points, I would say, is having insight but failing to act. That's something Brian and I talk quite a bit about. So integrate systems, right? Connect your monitoring software directly to your CMMS. Have it measured, have it documented, so you can always look back on that and define thresholds, right? I'm going to say establish clear PF intervals versus alarms, so the urgency is understood of what we're seeing, right? And assign ownership. Insights are useless if they sit in an inbox, right? Every alert must have a designated owner or somebody who's responsible for validation of that. And again, I'm just analysis paralysis. I got a note here that says analysis paralysis occurs when we treat data as the destination. In
Mm,
condition monitoring, the only successful data is data that results in wrench turning at the right time.
perfect. Nothing to add. Okay, you're up again, man. Jeez.
Boy. Oh, all right. We need to move through this quickly, so I need to
I know.
do what I want to do, right? You can tell I'm getting rushed.
But it's good. We stayed on the important slides. So
Well, we say it on the important slides. I'll just blast through this one and say again, if anybody wants a more in depth, we can discuss offline. But I like the framework of actionable, investigable, relevant, and unique. Right? I could give a 1 day seminar on setting alarms, or for that matter, not setting alarms. But the quick and dirty is constant speed, constant load system, like a fixed speed fan. The vibration or temperature should always be roughly the same, right? In a perfect world. If it changes, it's highly likely a fault's occurring. We're going to look in that. Setting alarms on, and I'm going to spend a little bit of time on here. I'm sorry, I missed it, but this is important. Setting alerts on variable speed or process heavy equipment is difficult. That's the bottom line. It's very difficult because you're trying to hit a moving target. In a variable system, the data changes constantly just because the machine is doing its job. So, for example, if a variable frequency, a VFD increases motor speed, right, the natural vibration amplitude is going to increase. And the dilemma with that is that if you use generic alarming methods, you set a static alarm high enough to account for a high speed operation, you will miss a failure occurring at low speeds, right? And be sitting there scratching your head wondering what's going on and why the tool was a piece of garbage and why it didn't work, right? But again, going back to what we started off an hour ago, it's all in how it's set up. So I would say be very careful with what that looks like. There's a lot more that goes into it. So to me, the value of condition monitoring is not measured by the ability to detect a fault, but again by that lead time provided to respond to that lead time. Again, we want controlled shutdowns, not catastrophic failure.
Agree. Only thing to add is, and people who are listening who use VFDs, make sure they're set correctly. I've been a part of so many organizations that have brand new VFDs installed, been running for years, and you come to find out they're not even configured right. And you were losing power, you were wasting electricity, you were having unexpected faults for no reason other than the VFD was not programmed correctly for the job. Oh, hold on. Oh, that was me. Okay. This was the next one, right, Missa? Okay. Sorry. All right. Using PDM to improve your PMs. And we talked a lot about this, right? Eliminating unnecessary PMs. As I alluded to before, you can have the best PM compliance in the world by doing the wrong work. And the way to know that is you're not generating any corrective inspection tasks. You're not finding any. You're not doing any failure finding. You're just doing work to be busy to show that you've done something. Do the right thing. Okay. Refine your intervals. You may find that you've been changing something every 5 years, when in reality, if you using condition monitoring techniques, you could go 10 years, right? So there's all different types of actions you can take by leveraging the information. And then, of course, planning and scheduling. If anybody listening wants to make the biggest impact from a monetary resource, whatever standpoint, plan and schedule work. Take everything else we said today and forget about it. If you plan and schedule work, you will make an impact on your organization. Anything to add, Matt?
No,
Okay, case studies and real world examples.
let's
Go ahead,
roll through
Matt.
it. Keep going. Next one.
Okay, go ahead.
Um, Again, I've said it probably 4 times now, but I'm gonna make that quote again. The value of condition monitoring is not measured by the ability to detect a fault, but by the lead time provided to respond to it, right? Again, controlled shutdown versus catastrophic failure. But to be great at early fault detection, um, you have to master the measuring te techniques that are involved, right? The software, the AI, anything else out there is not going to purely do that for you. And some of those are what we talked about before: ultrasonics, high frequency enveloping, shock pulse, time waveform analysis. Mastering those technologies, it will help you immensely in that.
Agree. My only recommendation here is if you have the opportunity to look at holistic information, including vibration, maybe CTs, RPM, whatever, you can make a more informed decision on the defects. And that's a big win. Okay. Key takeaways. Technology doesn't create reliability. People, process, and culture do. Full stop. Strong maintenance and reliability fundamentals must come before condition monitoring. Full stop. Plan and schedule. Understand your parts procurement, your criticality, your risk, your business, your operation, everything. Data without context leads to noise. Insights with expertise drive action. I don't care what sensors you have or how much data or how many AI things are blasting on you. Doesn't mean anything if you don't know what to do with it. Alert overload erodes trust. Yes, it does. If I hear something pinging at me all day long and there's no outcome from it, I'm ignoring it, right? Condition monitoring must be aligned with defect elimination and your business goals. I got to know what's wrong so I can get rid of it. I don't want to just keep doing PMs to keep doing PMs. Cross-functional collaboration turns condition monitoring into sustainable strategy. Yes, bring everybody in, everybody on the same page. Condition monitoring helps ops, safety, procurement, finance, the CEO, your brother, everybody. It benefits from condition monitoring and the tools and outcomes that come from it. Sorry, Matt, I skipped you. All right, Q&A.
Next steps.
Oh,
There we go.
right here. Okay.
Yeah. So real quick, because we only have a few minutes left and we actually have some really good questions to answer, I'm just going to touch on a few things. One, we will send out the recording of the webinar afterwards. We also, because we are a condition monitoring company, we offer a pilot program. We offer, I'm just going to give you the bare bones of it, 60 of our 3-in-1 sensors, which is ultrasound, vibration, and temperature in one for 60 days for $2,500. And we do the install, and we have our professional analysts working with you every step of the way. So little plug there. And then I have put our email addresses in the chat, so feel free to email us directly if you have questions. If you're interested in learning more about a pilot, email me, we can talk. And also I put a link to our predictive maintenance guide in the chat as well, which gives a more comprehensive step-by-step look at how to implement a predictive maintenance program. All right, and then the questions.
Yeah,
There was a
we got
really
time.
good one. Um, it seems the term CBM and predictive are used interchangeably. Yet by definition, at least in the EN standards, even though the predictive is part of the CBM, it requires the capability to tell, quote unquote, predict the remaining time to failure, correct? Like, is that correct? Using
Yeah.
condition monitoring, we usually know that degradation is taking place, yet very seldom do we indeed have a precise idea on what is the remaining time to reach the F point on the PF curve. What is your take on this?
So I'll just, before I let you go, Matt, I'll just say this. Condition monitoring is the tools to get you a predictive analysis. So you have to use condition monitoring tools to understand failure timeline, and then you use the data associated with the timeline and the failure to understand when that F actually drops on the P and F interval. Go ahead, Matt.
Now you hit it right on the head. We can beat this to death on the terminology, right? I mean, we have these discussions in our circles quite often. I think CBM, he's talking about condition-based maintenance, right? And predictive. I don't like using the term condition-based maintenance. That's just my preference. I just like saying condition monitoring. I leave the maintenance to the maintenance people. I'm not a maintenance person, but I am a highly tenured vibration analyst and condition monitoring individual. So the predictive side, to answer your question, again, I think that's where the experience comes in. Now, can you be 100%? No, but us old heads or anybody who's been in this business, we call it the $1 million question. And not every industry wants that answer, right? But let's say that you're working in a large facility. I like to pick on pulp and paper. Missa knows that. And you have a monster gearbox in somewhere, and they literally they're not going to pull the whole gearbox out if you see a fault, right? Um, and they want to know exactly what shaft and then how much longer they have because they know there's going to be a long lead time on that, right? So they can start getting people on the table and at the table and say, well, this is based on the speeds, based on the harmonics of what we're seeing, based on the amplitudes, bringing in based on the temperature, and based on that analyst who's been looking at that gearbox for 30 years, we can give I will say, an accurate, educated guess
Window.
on what's going to happen, better than any AI or fabricated alerts or alarms are going to do, because that's really where it comes in. And then the discussions have to be had. People have to sit down and discuss it, right? And bring their expertise to the table. The terminology, to your point, it's been doing nothing but muddying the waters. We've seen a lot of marketing and different things. People coming up with inventing their own terms and different things. I just call it condition monitoring, but the predictive side is just what I told you. It's taking all that information and making an educated decision on if it will or if it won't, based on what the scope of that work is going to be. Like I said, you have to open up roofs or cut holes in the side of a ship or something like that to pull something out. We're having those discussions. If it's just like a bearing on a conveyor or a bearing on something that people can run to Granger and pick something up for $10 on, that conversation's probably not happening. What do you think, Brooke?
Condition monitoring is the vehicle. Predictive is the end, the destination, right?
And
Great question.
I think one thing is that comes to my mind is the analysts, right? Because really having that expertise is the thing that's going to be able to give you the most accurate window of when you're going to hit the F point.
Yes,
Mhm.
but context is so important in
Yeah.
that statement. You can be an analyst who's been trained sitting behind a desk your whole life and you know a lot, but you've never set foot in a mill. then you don't have the contextual and environmental understanding of those assets and where they're performing their function. So
Huge.
you can't take that contextual environmental data and apply it to your analysis. That's why it's so important that analysts have been in the mills, have been in the plants, have been in the field doing this work, because they're looking at it differently than someone who's solely looking at data.
Agreed, agreed. Well, I'd love to answer the next question, but we do not have time. So it is at the top of the hour. And so we really appreciate all of you coming to the webinar. Like I said, we'll send out the recording afterwards. And then please do email all of us or one of us any questions you might have. We'd love to chat more about this. But thank you, everybody. And we hope you have a great rest of your day.
Thank you, guys.
Thanks, everybody.
See ya.